So continuing with question one, it also talks about a histogram. So a histogram is a graph that shows the distribution of the numerical data by grouping values in intervals or classes, if you will, categories. They also call them bins, and displaying how many data points fall in each group. So this is going to be more of a visual display, not a table. So again, we've already kind of did this. We got our frequency distribution already kind of laid out. That's collecting and organizing the data. That's going to be our frequency distribution. Notice how our frequency distribution, they simply say when you create a frequency distribution, make sure you don't have more than 5 or 10 between 5 and 10 classes. My other book says 5 to 20, but too many classes or bins will make it'll make the histogram too messy and too vague. So not too few and not too many. So in determining the class width, then bin width is going to be the maximum value minus the minimum value divided by the number of bins. So in other words, the number of classes, if you will. So we're talking about in our book classes, they're using the word bins here. So we also have the word classes. And I always round up to a convenient number. Usually we round up to the next whole number, but in this book here, it uses a number that makes better sense. Okay. So notice how here we have one, two, three, four, five, six classes. So this would be six bins, if you will. And one of the things we would do is count the frequency in these bins. Now, another thing to pick up on when we talk about this frequency distribution is the left side is called the lower bound and the right side is called the upper bound. So the lower bound or the class goes from 40 to 49. But notice how from 40 to 50, if you go from lower bound to lower bound, that difference is actually the class width. So notice how from 40 to 50 to 60, that's that class width. So notice how the difference between the first two lower boundaries helps us create what's called that class width. It's used to build the class limits, if you will. So that helps us kind of build our actual frequency distribution by first building the classes. So this helps us, like I said, create the frequency distribution. Once we have a frequency distribution, then we can now create the histogram. So luckily for us, the frequency distribution we've already kind of done that. Okay. And I don't know if we have to actually develop the actual whole frequency distribution. I think they give us half of the frequency distribution. We just have to create the other half. So when we create a histogram, notice how there's going to be this x-axis and y-axis. So it's kind of get back into our graphing in our math classes. Now, the histogram is actually going to have these bars, but the catch with a histogram is the bars have to touch each other. So it's important that the bars touch each other. Sometimes the midpoint is used to create the interval in the x-axis. The bar height is going to be the frequency of that bin. So in our question one, notice how we've already got the frequencies here figured out. So we had, for this example, it was 3, 7, 3, 6, 1, 7, 3, and 1. So that was our frequencies for this particular example. So it looks like this may be a little bit different than we had a minute ago. So for this example, we have 3, 7, 3, 6, 7, 3, 1. So notice how if we look at the x-axis, it's actually got this 25 and then 125. Or picking up on is they're not trying to label everything, but notice how if you look here, the class width is actually 50. The class width for this is actually 50. It's going 0, 50, 100, 150, 200, 250, 300. Now notice how there's this 25 here. Notice how that would actually be the midpoint of this. So if you add 0 plus 50, that'd be 20, that'd be a 25. So they're using a midpoint of about 25. And notice how the class width is 50. So what they're doing is going 75 or 25 plus 50 would be 75. 75 plus 50 would be 125. These are going to be the midpoints of each of our little bins, if you will. So the 25 is a bin, the 75 is a bin, 125 is a bin. But notice how really this is going from like 0 up to close to 50. So notice that the width of that bin is actually 50. So this is really going from like 0 to about 50, somewhere in that area. So if we look at ours from 0 to 49, that first one has a 3. So notice how this histogram would not be accurate because it's saying there's 3 there. Here, this one looks good. It does look like it's going up to 3 in the frequency. Between 50 and 99, in other words, they're using the midpoint of 75, if you will, they're saying the frequency is 7. Notice this frequency looks like a little bit low for that one. So for 75, we're getting 7. This looks a little bit low. So if I go down here to this one, again, we had 3 for the first one, but 7 should be the next bin. So notice how this doesn't go up to 7, so this one's out. If you look at the fourth one, notice there's a 3 there, there's a 7 there, 125. Looks like that's got 3. 125's got 3. If I keep creating these, another 50 would be like what? 175, 225, 275, and then what, 325 if I continue on through there. So at 175, I should have a 6. So that would be the next bin. Notice it looks like it's right at 6. 225, that would be 7. And then we have the 275 looks like that's 3, and 325 is uh, 1. So notice how the histogram, they're actually using the midpoint to create the bins. So that midpoint kind of came from halfway between these values here. Typically, a midpoint, we're supposed to add 0 plus 49 and divide by 2. That would be like, 24.5, if you will. But notice how that's about 25, if you will. So notice how they're using a little bit of estimation and rounding to make it look clean. So it's easier to count by 25s and 50s than 24.5. So they take in consideration that they want the information to look kind of clean. So again, your histograms, notice how the bars actually touch. They're continuous in that fashion. But notice how the x-axis was the midpoints, but the y-axis was the frequency. So, but instead of using the 0 to 49, they actually used the midpoint of 25. So that's where those numbers were coming from. But notice how that does match the frequencies here. So we do see that happening there. So luckily for us, I don't think we'll have to actually generate the frequency distribution all the way, nor do we have to create the histogram all the way. I think we just have to figure out which histogram matches this. So we're just kind of introducing these topics. If we do see more of it, then we may be able to develop these from scratch, depending on what the questions are. But right now, we're just kind of touching on just some vocabulary.